So in lesson 3.5, we're going to learn basically all the converses of the postulate and theorems that we learned in section 3.2. So in section 3.2, we had lines that were parallel already, but in this one, we do not know that the lines are parallel yet. And so we want to look to see what can we do to prove that they must be parallel based on certain angle pairs being either congruent or supplementary. So the first one we're going to look at is a postulate. So recall that a postulate does not need to be proven. We're going to accept this one to be true, and then we can use this postulate to prove future theorems. So this one has to do with the corresponding angles. So if corresponding angles are congruent, that's going to imply that we have parallel lines. So if we look at, for example, in this picture here, where we have lines L and M, if we refer to a pair of corresponding angles, say angle 2 and angle 6. So if angle 2 is congruent to angle 6, then L is parallel to M. Another way you can say this is the corresponding angles converse postulate. I like the abbreviation a little bit better just because I think it explains it a little bit more. In other words, if you have corresponding angles, right, if you have this first, then you can conclude that you have parallel lines. So that would be step 2. Next we have theorem 3.5. So this has to do with if you have two lines cut by a transversal so that a pair of alternate exterior angles are congruent, this implies that you have parallel lines. So let's say in this next theorem we want to prove this. Here's angle 1, here's angle 8. So that's going to be our first statement. Now we cannot use the theorem to prove this. We can use the previous postulate. So the previous postulate had to do with corresponding angles. Now we have many pairs of corresponding angles congruent here. So we could say 2 and 6, right? We could say 1 and 5, and again, that's if the lines are parallel. But right now we just know 1 and 8. But if we could get a pair of corresponding angles to be congruent, then we can prove L is parallel to M. So I look at, let's incorporate 1 and let's say 5. Well, if you take a look at 5 has to be congruent to angle 8 because, what's the reason? What kind of angles are these? These are vertical angles. And what do we know about vertical angles? We know that they're congruent. So now if we look closely, notice how they're both congruent to angle 8. So what does that tell us about angle 1 and 5? Angle 1 has to be congruent to angle 5. What would the reason be? Transitive. Well, what was I saying in the very beginning? Remember how if I said we had a pair of corresponding angles congruent, then we can conclude the lines are parallel. So if we look back here, sure enough, angles 1 and 5, they're corresponding angles. So when we have corresponding angles congruent, this implies parallel lines. Next theorem, and there is a little typo here. So this is supposed to say consecutive interior angles. So when consecutive interior angles are supplementary, then the lines are parallel. Again, this is a theorem. So now we can use the previous theorem since we have just proven that, or we can use the first postulate. So take a look, number 1, angle 3 is supplementary to angle 5. So these two here are supplementary. Now again, if I can get corresponding angles, or if I can get alternate exterior angles congruent, then we have the lines parallel. Since we have 3 is supplementary to angle 5, what I want to look at first is what other angles would be supplementary. Well, take a look at angle 1 and angle 3. Notice that they form a linear pair. So I know angle 1 and angle 3 are supplementary. Again, we need a reason. So what kind of angle pair did I say they were? I said they were a linear pair. What does this imply? That means they are supplementary angles. Now, why is that important? Well, take a look at these two statements. They both include angle 3. So we had a theorem in a previous chapter that said if we have two angles that are supplementary to the same angle or congruent angles, then they must be congruent. Now, why is that significant? Well, take a look at angle 1 and angle 5. They're corresponding angles. So we're back to that first postulate where it said if we have corresponding angles congruent, then the lines are parallel. Now, we still need a reason for this. Now, I actually said it in words. You can say, let me write it out. So angles supplementary to the same angle, or congruent angles, but I'm just going to write same angle, are congruent. You could also write this is the congruent supplements theorem, if you prefer to write that. Okay, so now once I have corresponding angles congruent, I can say L is parallel to M, and my reason is that corresponding angles congruent implies parallel lines. Okay, one more of these types of theorems. This one, the one we haven't gotten to yet, was alternate interior angles. So that also is going to be true if you have alternate interior angles congruent. That's going to imply parallel lines. So we have angle 3 congruent to angle 6. So here's 3 and here's 6. Now, since we're working with congruent angles this time, I'm not going to look at linear pairs, but I can use vertical angles. So if you look for a pair of vertical angles that will help us to get either alternate exterior or corresponding. I think corresponding is pretty easy because if you look at angle 2 and angle 3, these are vertical angles, and that will give us angle 2. So notice here, they're both congruent to angle 3. Therefore, angle 2 has to be congruent to angle 6. Reason is the transitive property. Again, why is this significant? Well, angles 2 and 6 are corresponding. Oh, and I'm missing a little m. But L must be parallel to M, and the reason is corresponding angles congruent implies parallel lines. Okay, these two we're not going to do proofs for, but if you have two lines are perpendicular to the same line, then they must be parallel. So if you kind of imagine here is a transversal, if these two lines, if this line is perpendicular to both these lines, then they must be parallel. And then the parallel postulate is not something we're going to use too often. It has more to do with something we'll see in the next section. But if you have a line and a point not on the line, there's only one line that would be parallel to this one that goes through that point. In other words, if you try to draw another line, it's just going to overlap that first one. Okay, let's take a look at example 1. So in the figure, and this figure is not drawn to scale, we have BG bisects ABH. Well, here's ABH. If this is 45, this is 45. which makes that whole angle 90 degrees. Again, it doesn't look 90 degrees, but we're just going to go with it. So clearly, let's see here, if this is 45, so this is 90. We don't know anything about these angles here to determine if these are 90 degrees. Actually, yes, we do. I'm sorry, I shouldn't have said that. Here we can see if this is a triangle here, if this is 45 and this is 70, then 45 and 70 add up to 115. If we subtract that from 180, this would have to be 65. Now, since we did that, we'll notice here these two angles are congruent. Those are corresponding angles, so we know DF is parallel to GH, and I think that's the only pair here. Okay. Next, here we want to find X and angle RSU so that these two are parallel. These are corresponding, so we'd want to make sure that they're equal to each other. So we get X equals 15, and then for measure of angle RSU, we have 8 times 15 plus 4, so 8 times 15 is 120, plus 4 is 124. Here, these two angles. Now, this is pointing here, 9x minus 5. This is 7x minus 3 here. These are not any special angle pair. But if this is 7x plus 3, notice those are vertical angles. So this one would be 7x plus 3 also. And then notice these are consecutive interior, which have to be supplementary if we want the lines to be parallel. So I have 9x minus 5 plus 7x plus 3 equals 180. So we get 16x minus 2 equals 180. So 16x equals 182. And we get 11.375. Okay, in example 4, we want to determine which lines, if any, are parallel and state the postulate or theorem that justifies the answer. So if, let's see, go like so, if 16 and 3 are congruent, well, those are, P would be the transversal, but it's going to make L parallel to M. And the reason is these are corresponding angles. Congruent implies parallel lines. Next one, I'll just use different colors, 4 and 13. So those are alternate interior. So again, that's going to be L parallel to M. And I just said those are alternate interior angles. Congruent implies parallel lines. Next one, we have 14 and 10. Right here's 14 and 10. These are consecutive interior to lines P and Q. So we know consecutive interior angles supplementary implies parallel lines. And the last one we have is angle 1 and 7. And again, that's going to be lines P and Q. And these are alternate exterior angles. Congruent implies parallel lines. And I believe that's it.